All right, here we go. Unit 4, Chapter 5 on lean systems. This is actually one of my favorite chapters because this is material that really can be put into practice at work and in many different ways, in small ways and large ways. So while we're going to be introduced to some Japanese terms in this chapter, it's we can use the American translation, the English translations of these, but the principles still hold the same. So some really good stuff. I want to give just the purpose of this recorded lecture is to really hit on these terms and help you understand how they fit together and let you get into the details and the readings. So again, we're on Unit 4, which is about lean. We're going to tie right into Chapter 5 to address this. And lots of different angles going on this. We're going to look there's several unique terms we're going to look at in this chapter. So let's just get on moving in on this. What is lean in a business context? And this really does come out of the Japanese applications. And this was particularly started by Deming, an American guy who traveled over to Japan after World War II and worked with Chinese manufacturers in rebuilding their manufacturing infrastructure. And since they were essentially starting from scratch, they were able to build systems a lot more reliably, a lot more modernized. And whereas the American automotive systems were evolved over time, and so there was some inherent um, uh, uh, unproductive practices built into them. So it's hard to rebuild when you start with what you already have. So with Japan, they were able to create some systems, and Toyota has certainly become the world hallmark of lean operating systems. So you see a lot of references to lean and Toyota in this process. So lean, I like the definition that it's a relentless removal of waste from an organization. The Japanese term is muda. You'll see that mentioned here and there. And so waste comes in many different forms. I'm going to give you some specific areas, and that's what a firm would look at when they were going into lean processing and they say, "Oh, we're going to lean our business." What they really mean is they're going to search for waste, and there's a model that you can use to of areas to look for waste because it comes in all different kinds of places and you don't often realize. And so this model kind of helps you identify where those are. So just-in-time systems is what we're really working toward, and that applies to all kinds of business processes, whether those are service-oriented or they're product-oriented. Certainly, it's most obvious in a product-oriented. And so conceptually, what we're looking at is just-in-time is rather than having materials and products and inventory sitting around just in time, just in case the customer needs it. So when you walk into Target and there's all these shelves full of all these products, you could look and say, well, they really aren't going to sell all those today. Why are they all sitting here today? That's waste. But there's a challenge with being able to reliably predict when customers are going to come into Target and want to purchase that specific item. So what we do is we forecast and we put inventory on the shelves and it's there just in case. And Lean says, no, 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 we want to design things just in time. So how do we make sure that things are only arrive at the time they're needed? And we can't do that often in a retail situation, but we can do it in a manufacturing situation. So previously, 20 years ago, 30 years ago, a manufacturing facility would be attached to a huge warehouse that was full of all of the parts and knobs and raw materials that you needed to assemble a car or assemble a laptop computer. And so you would have all that inventory sitting there, and then when the workstations need it, they would request it, or it would be sent over to the workstation, and they would assemble the computer or assemble the car. And what's happening now, and I've visited a lot of these plants, so it's really exciting to see it in place, is that the subcontractor that's delivering, let's say, tires for an automobile or interior seats for an automobile or steering wheels for an automobile is actually delivering multiple times per day, and they're bringing just the seats that are needed for that next 2 hours or 3 hours. And then they'll come back in 3 hours and bring the seats in the right color and the right style and everything for that vehicle. So just in time, and literally they bring it up to the line and the person takes it off the cart and puts it right into the vehicle. And so that's a source of waste, is having inventory sitting around before you need it. So inventory, movement. When I think about the Cleveland Clinic case that we talked about 2 weeks ago. And remember when it said the people would go upstairs to that old office that's no longer used because that's where we store the inventory and that's where they'd have to count it. And then they come back downstairs. And I'm immediately thinking that's lean, that's a waste. Why are we wasting the movement of going upstairs? It's going to take time, that takes energy. Why isn't it stored closer to where the person is? And there may be a really good reason why it's stored on the second floor. Maybe the people that use it are located on the second floor. But that's the kind of questions we have to ask when we're looking at a lean transformation, is question everything. Is it really in the right place at the right time? Is it creating an unnecessary cost? So here's the screen that you use. There's 8 types of waste. And if we were going to transform your personal life, your school life, your work life, your business, you would go through this and you'd question each one of these things. So overproduction means, are we producing things we can't sell or that we can't sell now? So, we have a quality problem. So when we need 8 of these, we always make 10 because 2 of them will be bad. That's a waste. Figure out why 2 of them are being produced bad. Fix that instead. Inappropriate processing. So are we using a more expensive tool or a more expensive process when something much cheaper or simpler could be used to accomplish the same outcome? Waiting. That means, am I sitting here and I needed information from my colleague down the hall and they don't have it for me yet, so I sit here waiting for it. I should have, did they not get it done in time? Did they know when I needed it? Coordination, making sure that things flow smoothly through the workplace. You see this in restaurants all the time, where maybe the kitchen staff is working frantically all the time, but the wait staff is sitting around leaning against the wall. It's like, oh, there's nothing to do because I'm waiting. How could we rebalance that? Do we need less wait staff if they're all going to be standing around? So removing waiting. Transportation, that can be moving it on a cart, that could be moving on a truck, a train, a ship, an airplane. It could be moving a box from my desk to the next desk. Do we really need to move it? And you've seen the transformation where instead of printing papers and signing papers and then sending papers in mail or carrying them down to the next person, we do those forms electronically and they get sent electronically over to the next place. So removing any unnecessary movement. Motion in general. And this is even from the standpoint of, if there's something that I use all the time in my work, is it here on my desk? Is it within reach, or do I have to get up and go around to the other side of my office and get it out of a drawer? Well, if it's something that I'm going to use all the time, it should be right here, accessible from my desk, from where I am working, right here by my computer. Inventory, that's the big one, and companies save millions of dollars by making sure that inventory arrives when it's needed. And the reason we don't want it early is a lot of things can happen to it. If it's fruits or vegetables, it can spoil. If it's valuable, it could be stolen. It could be lost. It could be damaged. It could be no longer needed. So I ordered 1,000 rolls of paper towels, and now we've changed paper towel dispensers and they no longer fit. Now what am I going to do with those 1,000? Oh, I bought a year's worth because they were cheaper. But now you get to throw a year's worth away. So lots of little things go on that. Defects, we talked a little bit about that. Are we spending time building things that are not going to work? And why are we doing that? It's going to create even more cost. And the new one is number 8, underutilized employees. And that's where you have a person that's qualified to do a much higher value task, but they're stuck doing a very low level task. And so we want to, over time, get people into the place where they create the most value and that they're also able to earn the best income for what their skills are. So lots of different ways. I hope you're already thinking of restaurants you visit, stores you visit, places, insurance office, your own work, and there's waste everywhere. And when we can start to eliminate some of that, it really can hits the bottom line. All of these wastes hit the bottom line, even if it's the motion and I'm going to the other side of my office to get something. It's like it's taking time that I should have been able to just keep working, and now I got to stop and I got to go over and I got to get it out of the file drawer, and the file drawer is locked, and now I got to find the key. Just waste. So it's just so many opportunities for us to improve that. Um, Another part that comes out in lean is moving from a push method to a pull method when it comes to workflow. And a lot of times, again, we think of inventory because it's physical and we can see it, but this also happens with electronic workflow, with document workflow, with any type of workflow. If somebody needs to come into the office and see person one and get something signed and then come to person two and then come to person three, think about when you go to the Department of Motor Vehicles to get your license reissued, or license tags, or your title to your vehicle. It's station after station after go sit in chairs and go fill out a form and sign it and then go back over here. It's extremely inefficient. Push method is the traditional method. That's bad. And so if you think of inventory, we push inventory. We push inventory to the store. So the distributor pushes paper towels to the Target warehouse, and the Target warehouse pushes it to the storeroom in the actual store. And then the employees put it on carts and they push it out to the shelves, and they put it on the shelves, and then everybody sits around and hopes that the customer's going to come in and buy it, which is inefficient because we may be pushing around inventory that nobody's going to want. A pull method asks us to just reverse that whole process and not have the inventory available until the customer arrives, or at least delay the finishing of that product to the last minute. So if you think of restaurants, we don't, other than at McDonald's, if you go into a restaurant, they don't pre-make all of the meals and they're sitting there, and we hope the customer shows up, and they don't, then we throw it all away. So you come into a restaurant like Chipotle and the raw materials are there, and then, oh, if you want a bowl, then they assemble it in a bowl. And if you want a burrito, they assemble it into a burrito. And so at the last minute, we put it together, and the customer pulls that demand. Oh, I want cheese, I want beans, I want this kind of meat, so we build it at the last minute. Amazon on delivery is almost a pull method because they position the inventory around the country, and I can order it and have it same day. I can pull that item and have it almost immediately when I need it. When it comes to a manufacturing process, that's something we're going to talk about, another little nuance here in just a moment, is when you're thinking about a workstation where the car is coming down the assembly line past you and you need to put the wheels on, then rather than having 12 stacks of wheels all piled around you, and it might be the wrong wheel, is that a cart comes up behind you that has the right wheels on it. As the car comes in front of you, you turn around, you grab the wheel, you put it on. It goes down the line, the next car comes up, you turn around, and oh, the right four wheels just showed up. That's a pull method. So I'm not going to pull those components down the line until I need them. It takes a lot of coordination. It takes really reliable suppliers. But then you don't have inventory sitting around. Inventory costs you money because you have to pay for that inventory, and you don't get money for it until you sell the product. And then all those bad things that I mentioned could happen to inventory. So here's two other items. These are, again, Japanese terms. This is all the different dimensions of lean. Jidoka is quality at the source. I mentioned this last week. That means every person in the process, in the organization, is responsible for quality, and that authorizes everyone in the organization to stop the process if there's a quality failure, which is really pretty huge. I visited manufacturing firms where literally that's the opportunity, and a person on the assembly line has a button in front of them, and if something comes in front of them and it's not right and ready for them to work on, somebody up the line made a mistake, they hit the button, and that stops the entire line, and we go figure out why this unit isn't right, and we go fix that problem, and then we start the line again. The other term that doesn't come up in our text is called an andon light, A-N-D-O-N, and I've seen these in the factory. They're really interesting because you look across this, multi-million square foot factory, and there's these bar of lights, almost like a traffic light. It's green on top, it's amber in the middle, it's red on the bottom, or reverse. And if an employee is working on the line and the material is sliding down past them, and for some reason they're not able, it's moving too fast, they hit the amber light, and it shows everybody in the plant that we're going to slow down right now. So don't rush pushing material to me because my machine has a problem, or I need to change the bit in the machine, or a light bulb just burned out. I have to replace the light bulb, or I need to go to the bathroom. So it slows down the entire line so that people don't make things we don't need, we can't process, and they pile up too much. And then when everything's working, I hit the button again, it goes back to green, and everybody goes along. I've also seen this in a plant. It was really cool where there was music playing, and the music played faster when things were green, and the music slowed down. It changed the pace of the organization when there was amber or there was a red system. So andon lights, andon can also be done musically. It's really kind of funky. Poka-yoke is another Japanese term, and it means designing your process so you really can't make an error. If you have an online fillable form, have screenings in the form to make sure that fields with numbers get numbers and fields with letters get letters, and you can't mix the two up, and phone numbers have to be valid and email addresses have to be valid. It's creating systems that when people use them, they can't inherently make mistakes. Just a lot of good things. This is actually one of my favorite. This came up last week. 5S. And it's actually 5 Japanese words. They're down in the lower box. I'm not going to try to pronounce them because some of them might not go well. But we've converted them to 5 English terms. And we call it sort, straighten, shine, standardize, and sustain. And what that means is organizing our workspaces so that what we need is ready when we need it, ready to use when we need it, is standardized. So if mine breaks, there's another one down the row I can get, or I can get one from the supply cabinet. It's clean and ready to go, and the system is sustainable, that it can be maintained easily over time. And please look for this when you go out and visit firms. This is my coworker's desk. Now you can see this is the 1990s because that's an IBM XT computer. So that is dark ages. Look at that monitor. Probably weighed about 60 pounds. This was my coworker's desk when I worked at Baltimore Gas and Electric, and I still remember his name. This is not 5S. This is a mess. I see 2 coffee cups, and everybody always says, "Oh, don't worry about him. He knows where everything is." And it was true. This guy could actually reach into that mess and pull out whatever report you needed, whatever document or book you were looking for. But the problem is, what if he's not there? What if he's out sick? Who's going to find anything in this mess? What if that coffee cup spills over? That is not how to work. That is not 5S. 5S, the definitions are right in the text, so I'm not going to get into these all specifically, but this is what 5S looks like. So on the left-hand side is just a messy storage cabinet. And a 5S one has everything labeled, everything's full, everything's correct. There's nothing, no expired materials. The right quantity is there. And so if I need this and I go to the cabinet, I can get exactly the item I need. And then there should be a system in place that it'll be replenished. So things like, what staplers do we have in our offices? We make sure that all the staplers are the same, because then we only need one type of staple refills. It isn't, oh, well, my stapler uses this kind and the wrong ones are in the cabinet, so now I can't, now I have to borrow a stapler. That's not 5S. 5S, and this stapler, because I use it all the time, is right here on my desk where I can reach pretty much from my chair. I don't have to get up and unlock anything. The pens are on my desktop. My Post-it notes are on my desktop. My highlighter is on my desktop. Everything I need is right here on my desktop in the right place. So if I look down and my Post-it notes are gone, that means somebody borrowed them and didn't return them. And I can, before I sit down to get started work, I can go replenish them, or I can get them back. So that's why some people, and I've seen engineers do this, which is a little scary, they will actually put labels on their desk. This is where the stapler goes. This is where the Post-it notes goes. This is where my highlighter goes. You don't have to go to that level, but it is about having things organized and in the right place. The nice thing about labeling them is you can quickly tell when something's missing. And if someone borrows it, then they know where to put it when they come back. So this 5S stuff can really be transformational in the efficiency of an office. The next level, probably the toughest item we need to talk about, I'll wrap up with, is Kanban or Kanban. It's another Japanese term. And what it means is it means visual signal. It's not a really complicated word, but the interesting part is how we use it. And so you often use a Kanban or a card system in the manufacturing plant. And this is how you execute a pull system. And so if I'm sitting at my workstation right here in front of you, and I'm assembling DeWalt impact drivers, those nice yellow and black tools, and I sit here and I put the switch in each of those as they come down the line in front of me, and I put the little figure trigger switch in them. What a Kanban would do is there would be a bin beside me that had switches in it, and maybe it has 20 or maybe it has 30 in it, and they would all be in individual slots. They wouldn't be all tangled up. It'd be very clean and very set up. And then as the tool came past me, I'd reach over, I'd take one out of the box, I'd put it in. I'd take one out of the box and put it in. There'd be a Kanban card on the end of that container. And so whoever's getting the switches for me would not just have piles and piles of switches piled behind me. There would be one tray or maybe two trays. Let's say there's two trays, that'd be even better. So then I use up one tray, and then the Kanban card, I would hang it up on a high spot over my cubicle, because then the person down the row who replenishes switches would see it. It's a visual sign, and I'd be pulling another container of switches, and they would literally come down, take that card, go back with the container, fill it with switches, and bring it back to me. And the timing would be so that when I finish up the second bin of switches that I have, they would be bringing the next one back to me, and I'd put that card up, and they'd go start replenishing, and I'd use up that one. And so it'd be just a continual cycle, and I wouldn't have just piles, and I wouldn't sit there and go, oh, I don't have any switches, I can't do anything. So a Kanban is just a visual sign. It would have the item number on it, the quantity, any special features of it, where it's stored, all those kind of things. And you see this all over the place in manufacturing plants. Now, warning, there's two types of mathematical problems that you'll need to solve in this course, in this chapter, and I'll put together some different materials to support that. But the one is, there's a mathematical formula to calculate how many Kanban cards do you need in a system, and it has to do with measuring the flow in the system outbound and the flow in the system inbound. It's a rather simple equation. You plug in the values, and it tells you how many Kanban cards you need in the system. And if you have that number, then there's that, and how many number of Kanban cards you have is how many containers you have full of that material. And full might be 10, it might be 20, it might be 50, but a container is usually a little bin, and it would have that card on the end of it. And so depending upon how many go in the bin and how many I process during that shift and so forth, you can calculate how many essentially bins you need, or how many Kanban cards. Fairly simple equation, but that's something you'll have to solve in this chapter. The other one's kind of cool. It's called takt time, and I alluded to that. And that's the rhythm of the operation. And in a manufacturing facility, that's really important. If you've ever driven on the Garden State Parkway, the rhythm is a real problem. If everybody's going 50 miles an hour, everything works great. If everybody's going 30 miles an hour, it actually works okay. But if some people are going 50 and some people are going 20, it's stop and start all the time, and it's just a mess, and there's accidents, and it's just horrendously difficult to drive in. And takt time, takt means rhythm. And it's almost like a metronome if you've seen one of those on a piano, and it keeps rhythm. And so takt time tells what is the rhythm of your operation based on the processes that you are doing. And again, I've been in facilities where the takt time, you can actually look from a viewing platform across the entire operation, and you can see the synchronization, and the materials are just moving, and the forklifts are driving and dropping off materials, and it's almost like there's music playing, and everybody's on the same rhythm. Pick it up, move it, assemble it, push it, and everything just works so nice and nobody's waiting. So if you don't have a good tact time in place, then there's going to be people sitting around doing nothing, and there's other people that are going to be working frantically to keep up. So calculating your tact time sets the rhythm of the entire operation. It's really cool when you see it in place. I wish I had a video of some of the plants I visited, but when it's working, you know it. You can actually see it in restaurants if you're really observant. You can tell the order placement, the pace that people are seated, how that initial contact is made, the initial order, the drinks come, then the rest of the order is taken, and then the order is placed at the kitchen, and there's just a rhythm to the place, and it makes it so much more pleasant. So you can see it in manufacturing, you can see it in services, but tact time is a calculation of what that rhythm is. Is it fast, or is it really slow, or is it somewhere in between? And the goal is it's not good if it's fast or good if it's slow. It's good if it's consistent across your operation. So that's kind of the big topics for the week. It's kind of a fun chapter. These are absolutely things that you should be able to put to work in your workplace and start transforming your own organization.